Hello students, welcome to the series which covers Term 2 syllabus for Computer Science class 12th. In the series first we are going to learn about data structures, which is the first unit in Term 2 syllabus. So what is data structures? Data structure is an organized way of storing data. It has a definite set of operations, behavior and patterns. It is used to store collection of data, relate them and perform some operations on them. So data structure means a collection of data which is stored in an organized form, and of course we can perform some operations on them. In Python, the data structures are broadly classified into two units. One is inbuilt data structure, the other one is user-defined data structures. Inbuilt data structures means which are already there in Python, which may not require additional program to implement them. They are list, tuple, set, and dictionary. As we know, list is a collection of data items separated by comma enclosed inside square bracket, and we have already done so many operations on list in class 11th as well as in 12th, term 1. Now, tuple is a collection of data items stored inside parentheses separated by comma. And dictionary is a collection of data items stored in key value pairs separated by comma enclosed inside curly bracket. These all are learned and we practiced many programs on this. Now, user-defined data types. User-defined data types may be defined by the user. That means we may need to program to implement them. These are stack, tree, linked list, graph, hash map, and queue. In Term 2 syllabus, we only need to learn about stacks. So let us directly go and see how to implement stack. So what is stack? Stack is a linear data structure that stores data items in a last in, first out, LIFO manner or first in, last out, FILO manner. So last in, first out means the item which have entered into this stack as a last item has to be removed first. Just imagine that you have a container just enough to fit in some balls inside it, and you are going to put balls inside that container. Suppose you are putting a green ball first, then an orange ball, then a red ball. If you want to retrieve the green ball, you have to remove the red ball, then the orange ball, then you can take out the green ball out. So the item which entered first into the stack can be retrieved as the last item. Okay, that's what first in, last out means. In reverse manner, if you think, the red ball which entered the stack as the last item is been removed first. That's why it is called last in, first out. Let us see the operations on stack. There are three operations mainly which are performed on stack: push, pop, and peek. This word has to be by hearted or understood by you students very thoroughly. Push means entering data into the stack. So if you are inserting a value into the stack, this operation is called push operation. So if you are taking out a value from the stack, it is called pop operation. So you cannot use any other word here. Pop operation on a stack means you have to remove one element from the stack. Push operation of a stack means you are entering an element into the stack. Clear? Now the last operation is peek. Peek means just peeking at the top of the stack. That means you are just looking at the top of the stack that what is the item now at the top. Okay, so peek operation always returns the last item in the stack. Is that clear? Now, let us see the push operation. Initially, you can see that there is a container which is empty. And into that container, in the second picture, if you see, we are inserting a ball, green ball. So initially the stack was empty, and this is called underflow condition. There is no element in the stack. When we have inserted a green ball, it went and it been pushed into the stack as the first element. Then we inserted two more balls into the stack. Now the container or the stack is full. When stack is full, this condition is called stack overflow. No more item can be inserted into the stack. So this condition is called stack overflow. Pop operation. When you remove values from the stack, it is called pop operation. Only pop operation can remove values from the stack. So here we have a container full of balls. So we are going to remove the balls. So when we removed the red ball, we had two balls inside, orange one and the green. Then gradually we removed the orange one and then the green one. Now our stack is empty and this condition is called underflow. Now peak operation. Peak operation means displaying the value at the top of the stack, or peak operation can return the value at the top of the stack presently. So when we do this operation on our stack which is full of balls, then the top element returned will be or displayed will be red. Then when we remove the red ball from the stack, we have the output of peak operation as orange. Then when the orange ball also been removed, we get the output as green. So, my dear students, I think now you all have a better idea about what is stack and what is push, pop, and peak operations. Now it's time to implement all these operations using our programming language Python. So, first of all, I will be declaring an empty list s equal to empty square bracket. This will be making an empty list. So after making this empty list, we have to do all these operation on this list: push, pop, and peak. One after other, we will implement functions to do all these operations. So let us first make function to implement push operation. So to create a function, we will be using def, and then the function name. Here I am giving the function name as push, and I am going to receive this stack as the parameter of this function. So here I am naming the stack as st for this function only. Now I am asking the user to enter an element. So user will be entering an element, and this particular element I will be pushing into the stack. So x is the value entered by the user. Then I have to add this element into the list. So what is the function to append an element into the list? Append function. So I will be writing st.append, and I have to pass the value x. So this is successfully done. If I would have been doing this program in any other programming language, I have to check the condition whether the stack is overflow or not. If the stack is overflow, we cannot enter more values into the stack. Here in Python, list has unlimited size. So if you are implementing a stack with list, overflow condition may not occur. That's why I am not checking that condition here. So let us call this push function and see whether it is working fine or not. So I have called this function, and let us run this. Here I have received an instruction to enter an element. I am entering the value 34. As you can see, I am not receiving any other instruction because I haven't given any print statement after entering the element. So let us go and modify our program a little bit. So I will be adding all those messages which I want to see in the output. Here I will be giving a message that push operation done. Okay. I also want to see the output or the contents inside the stack. So I'll be printing the stack also after the push operation so that I can see the value which I just now entered into the stack. Enter an element. I am entering 34 again. So I received the message push operation done, and then the content of the stack also been displayed, which is 34 inside a list. Let's call this push function few more times and print the content of the list. So I am just copying and pasting it here. Let's run this code and see how it is getting executed. Here I've been asked to enter the element. I am entering a 34. Then 34 is printed. Then I've been asked to enter another element. I am entering an 89. Then my list is being expanded. Now two elements are there, 34 and 89. Now I've been asked to enter one more element. I am entering a 45. So I have 34, 89 and 45 inside my stack. Is that clear? I have removed all the push and display functions. Now I am going to make the next function, which is pop. So we are defining the pop function. Pop function also will be receiving this stack. Now inside pop function, we have to check whether there is any element in the stack to be removed. Sometimes what happens, the stack will be empty. If the stack is empty, there is nothing to be removed. So that message must be given to the user. So here, first thing we have to check is whether the stack has any content or not. To check that, I am going to write one more function here. The function will check, it will simply check whether the stack is having an element or not. That's it. No other thing will be done in that function. So I am naming this function as empty, is empty, and this function also will be receiving this stack, and this function will check whether the given stack is empty or not. I will be writing if st equal to double equal to चाहिए. If st equal to empty bracket, that means the stack is empty. Or else you can also check this condition if length of st is equal to 0. That also means there is no element in the stack. So any condition you can use. I am using this condition here. If the stack is empty, then what this function should return true. So this function will be returning true if the stack is empty, else it will be returning false. Inside our pop function, first we will check whether the stack is empty or not. This will be done by calling the function isEmpty. If isEmpty of st, then you have to print stack is empty. Okay. Then else, if the stack is not empty, then we have to pop the last item in the stack. How to remove the last item in the stack? For this, we will be using the function pop that works upon list. So we will be using a print statement, or else you can assign this value to a temporary variable temp equal to st dot pop. If we call this pop function without any argument, it will be removing the last element from the list. So I have used temp equal to st dot pop. Now I can print a message saying that the last item, the item popped is, or the item removed is inside temp. The item removed is inside temp. I can print and give the message. So pop function is also done. Now we can go and call this function inside our main. So let us call this pop function now. I will be calling this function without calling push so that I can see whether this isEmpty function works fine or not. So I am passing an empty stack to the pop function. Let us run this code and see how the output comes. So you can see that stack is empty. That message is properly executed. That means pop function as well as isEmpty function work fine. Let's now write some push function and then pop function. So I am writing two push function here. Twice I am going to call the push function. Then I will be removing one value from this list using the pop function. Okay. Now run this code and see how the execution appears. Here two values I have to insert because two push function is there. So I have inserted a 25 and 56. So I got the message item removed is 56. 56 is the last item entered that been popped out. Okay. Let us now write the last function which is peek function. So peek function also will be receiving the stack. And here also we have to check whether the stack is empty. Peek function is going to return the topmost element in the stack. If the stack is empty, there is nothing to return. So we have to check that condition first. So here also we will be writing is empty and inside this we have to pass the stack is empty stack. If it gives true, we have to give the message print stack is empty. You can also write stack underflow. Else we can write code to return the last element. Last element of a stack will be stored in the -1 position. So I am using that. -1 index position of st will be containing the last element of entered in the stack. So I am taking that element into a temporary variable. Now I print the message print the element at top is temp. So peek is done, this much only. We are checking whether the stack is empty or not. If the stack is empty, we are simply giving the message. If the stack is not empty, the element at -1's position will be the topmost element. So we are giving that message. The element at top is at temp. So let us run this code and see. Here I am going to call this peek function. After to push, I will be calling this peek function. And after the pop also, I will once again call this peek function. Now let us run this. Enter an element. I have to enter two elements here since I have written two push function. So two push operation is being done. Two values is been successfully inserted into the list. Now the element at the top is 25 since 25 is the last item entered in the list. I have executed a pop. So one item is being removed from the stack. So presently the element at top position is 12. I think execution part is very clear to all. Let's write an additional function to display the entire content of the stack in a stack format. That is last item first, then the second last item, so on to the first item. In this format, we need to print the stack. So this function is a display function. So we'll be writing display. This function also is going to receive the stack. Then inside this function also we have to check whether there is any content inside the stack or not. If there is no content, then we have to give the message stack is empty. If there is content, then only we will be displaying the elements. So we'll write that condition is empty. If is empty st, if it gives true as result, then we have to print what? Print stack is empty. Okay. Else we will printing all the data inside the stack. I'm going to use a for loop to print the elements in the list in reverse manner. Since I want to print the elements in reverse manner, I am going to run this loop in reverse manner. Why in reverse manner? Because I want to print the elements in a stack format. Here in stack format, last item to be printed first, then second last item, and so on. To get the last item's index value, I am using the function len of st, and -1 will be giving the index value of the last item. And up to when I should run the loop? Up to -1. And in which format I should run the loop? In reverse format. So -1. Then here I will be giving the print statement to print the value inside the stack. st of I. This will print the value inside the stack in reverse manner. So here I am going to call this display function display s. Now let us execute this function and see how it comes out in the output screen. I have to enter an element. I have entered 58, and now I have to enter another element. I entered 45. So display function worked fine. It gave me 45 and 58 as a result. Now, like I said, I am going to make some changes in this display function so that I can get an illusion of original stack. So I am giving an end command and I am printing an arrow like structure. After print is done, I am also going to print an empty line so that this end can be broken. Okay. Now let us write the menu for executing all these functions together. Let us start writing the menu. I am simply printing the menu here. Print 1 for push. Likewise, print 2 for pop and print 3 for peak and print 4 to do what? Display. Okay. Then last is print 5. This is to exit. Okay. So I have printed the complete menu. Now let us call this function according to the menu. Now let's take the choice from the user. Choice equal to int input. Enter your choice. So user will be entering one of the item from the list 1, 2, 3, 4, 5 may say. He will be choosing one item. Then according to the item, our program should branch. So I'll be writing if C equal to 1, what operation to be done? Push operation to be done. So what function we need to call? Push function we need to call. If ch equal to 1, we will be calling push function. And elif, I am using elif condition because I have to add so many conditions here. Elif ch equal to 2, we will be calling what function? Pop function. Okay. Elif ch equal to 3, we have pop peak function to call. Okay. So in these functions, we have to pass this s. I forgot to do that. We have to pass s like this. Okay. Now, next elif ch equal to 4, what we have to write? Display function. Display s. Okay. Now, if the choice is the last one, that is the fifth one, what we need to do? Elif ch equal to 5. We will be breaking So how we will break? We haven't given any loop. So we have to give a loop. We will be giving the loop soon. So let us write the break now. Now the last else condition. Else, if somebody enters some other value like 6, 7, 8, 9, 10, some other value which is not in the list, if somebody enters like that, we have to print invalid choice. Okay. If I execute this program now, I'll be able to see this menu printed only once. This complete menu will be printed only once. So if I choose option number 1, I'll be able to enter one value inside the list. And none of these operations will be performed because after executing push, this if will be completed and program will end there. So if I want all after this entering value, if I want to do perform a pop and I want to display the value, I should get this menu inside a loop. I should get this menu again and again. After the push operation, I should see this menu again so that I can select other function. So what I am going to do is I am going to make this entire menu and the if selections inside a while loop. Here you see, before starting this menu, I am going to add this loop here. And the entire content after this will be made inside the loop, while loop. Now you can see that this complete program is inside the loop. We started from push and pop, peak, display function. Then when our main program started, everything is inside the while true loop. Now let us run this program and see how the output appears. The program got executed. We got our menu printed. 1 for push, 2 for pop, 3 for peak, 4 for display, and 5 for exit. So I am selecting the choice 1 first so that I can enter the element. So I am entering a 10 here. So I am getting the menu once again. So let us enter our next choice, that is again 1. I am entering 20 as the next element. I am getting the menu again. I am selecting 1 and I am entering the element 30 this time. I am selecting 1. I am entering the element 40 now. Now this time I want to see the elements in the list. So I am choosing the display, option number 4. So I got my display 40, 30, 20 and 10 in the same order how it should be displayed in a stack. Now as for next choice, I am going to remove one element. So I chose 2. So the item removed is the topmost element, that is 40. Now I am going to see peak. So I chose the option 3. So the element at top is 30. Now again I will go for display. Now the elements are 30, 20 and 10. Now let us exit from this menu by pressing 5. So this is it. So we have successfully implemented stack using list and we have seen all the functions push, pop, peak and one more function display. We also implemented a menu driven program to execute all these functions using list. So that's all for this session. In next session, we will be coming with the next chapters in the STEM 2 syllabus. Until then, keep learning.